Uh, so, so this is a one we can say that is revision class or doubt class. Under this, we are going to be study about the thermal stress or temperature stress, and temperature stress and thermal stress are the important because the any materials any somehow they have to be exposed in the temperatures. So what kind of stresses that develop inside the material, that is called the temperature stress or temperature thermal stresses. So under this we can see that we have a bar which having the diameter d and length l. If if the temperature of environment is increased by 30 degree, so definitely there is some expansion in the dimension of that bar. So due to that expansion, one kind of stresses in develop inside the material, and that stress is called the thermal stress. So you can see this is a bar and it is a both side, it is a fix, and then temperature has been raised by del T degree centigrade. So, so you might be studying the physics, the free thermal expansion. The formula for the three thermal expansion is alpha del T into L, where alpha is the coefficient of thermal expansion, you can say, coefficient of linear expansion, we can say. So this is this is a simple formula. We know that alpha del T, this is called a free thermal expansion. In another term we can say this is the change in length if you compare with the conventional stress developed in the any material. Okay, so this is the free thermal expansion alpha del T L. You know that this is called equation number one. So if you know that the change in length in the bar is alpha del T L, directly you got the change in length. So if you divide by L, so change in length upon original length is called the strain. So once you have alpha delta L, you divide by the length L, so you will get the strain. And because this is because of temperature or temperature, so this is called a temperature strain or thermal strain. I think you are getting my point. Now, how to get the thermal stress? You just, if you have a strain, you multiply by the Young modulus, so you will get the stress. You have simple, relation of Hooke's law. Sigma is equal to sigma, matlab stress is equal to E into small e, where small is strain, capital is the Young modulus, and sigma is called a stress. So you will get the thermal stress with the help of this, with the help of this formula that is called alpha delta E. And how much the compressive force develop in the bar. So once you know that stress and cross-sectional area of that bar, so you just multiply by the stress and the bar, cross-sectional area bar, so you will get the compressive stress and develop in the bar, and compressive force develop in the bar, and this force always in the compressive nature, because the thermal stress or temperature stress condition is that only produce if the both end of the bar is fixed. If one is free, no stress is developed, but expansion takes place, but stress will not be developed. So this is the point. So for getting the value of, if somebody is some examination, it's asked a bar is one in the fixed, another in the free, and even other parameter or given and asked something, what is the thermal stress? So there will be a new thermal stress. For getting the thermal stress, you have to be fixed both. otherwise it is freely expanding. So this formula, simple formula, you can use for getting, for calculating the thermal stress, thermal strain and compressive force developed in the bar. So yeah, आप इसको बहुत आसानी से, you just remember by the comparing which last time I taught you, how to get the stress force upon cross sectional area, then stress just multiply by, divide by E, like this. So you know that how to find out that. And strain, you can calculate the change in length upon original length. And so this is the some methods, simple small formulas by using you can calculate the stress, strain and applied load in the case of thermal stress. So this is now simple simple problem is that how to solve the problem based on the thermal stresses and liquid. So this is a simple problem. A rail, you know that what is the rail? Rail line is laid so that there is no stress in the rail at the 30 degrees centigrade. So no stress at the 30 degrees centigrade. The rail are 30-meter long. Though that rail, the length of the rail is 30-meter long. रेल मीन्स दैट वो जिसको आप यू कैन से द पटरी जिसमें ट्रेन चलती है, दैट इज रेल. So the rail are 30-meter long and there is a clearance of 5 mm between the two rail. There is a 5 mm of clearance. Okay, and you know that the railway is providing the certain gap between the two rail because of this phenomenon. And so if the temperature of the rail, if the rail rises to 60 degrees centigrade, so that what is the stress developed in the rail? So alpha is the coefficient of thermal expansion for the rail material, that is a, okay, 11.5 into the power minus 6 per degree centigrade, and E is equal to 210 gigapascal. So, my dear, most of the things are given in the question. L is given, alpha is given, E, and modulus of the material is given. Temperature, change in temperature is given 60 minus 30 is 30. Then free thermal expansion in the rail you can calculate by the formula alpha delta L. What you obtain in the just before. So put the value of alpha delta L and you will get the free thermal expansion. So what the question asks you, so you find what is the stress developed in the rail. So simply you can calculate, you can get, first you have to calculate free thermal expansion, then strain, then multiply by EA, you will get the stress. Simple like this, you can say. So see, one thing try to be understood, my dear. So see, try to see the free thermal expansion is how much is 10.35 mm. This is a free thermal expansion, but 5 mm the clearance is provided. 5 mm clearance is provided between that. So when the rail is treble 5 mm, so there is no stress, there is no strain. After that, after the 5, when the two rail are start in contact, then stress is start coming. So you have to minus this 5, like this, you see the clearance between the rail is 5, to free thermal expansion prevented by the rail, how much it is that prevented by the rail, you have to be minus 10 minus 5, so you will get 5.53 mm. Then strain developed in the rail is just 5.35 into the length of the rail is 30 meter, and you meter ko convert karo in mm, so you will get where you will get the 30,000 mm, and you will get this much of strain developed in the rail. And compressive stress developed in the rail, that you know that you just that this parameter you just multiply by the E is given 210 in the power 3. So you will get it actually it's given 210 gigapascal. Gigapascal is equal to, you know that 10 की 10 का power 9, 10 to power 9. So why I have written is 3, because of that is a 10 power 9 Newton per meter. Now here the everything is in mm. That's why directly written that it is 10 to the power 3, because here it is in Newton per mm. So Newton per mm is this, and this is a unitless quantity. You multiply, you have got that Newton per mm square. So Newton per mm square you can write as megapascal directly, because Newton if you convert the Newton per mm square into Newton per meter square, so 1 10 to the power minus 6 is come here. So that 10 to the power minus 6 is called a mega. That's by, and Newton per meter square is called Pascal. So that's why we have written here directly mega Pascal. So the compressive stress developed in the rail is this. So this is like this problem what you have seen. So there was a single bar. Now, if there is some composite structure, composite system is there, then how to calculate the thermal stresses? Is there is any methods? Yeah, we have that method. So thermal stresses in the composite bar. This is a bar made of two material. One inside is copper and outside is steel. So inside copper, outside is steel. So what will be the free thermal expansion or a thermal stress or stress developed in this material in this structure in this condition when the bar is composite. So in the case of bar, my dear, you can see that the inner material is this and outer is this. So they are fit. And one side we have assumed that it is restricted. Okay, this side is restricted. This side. So there is this side no, like this. There is no any expansion in this side. So you try to be understand. Copper and steel, the coefficient of thermal expansion of the copper is more than steel. ये you you are you might be studied in your 11 or 12 standard the coefficient of thermal expansion. You know that the copper is much more, you know, expansible material and also then steel. So it's a clear that definitely the if the temperature increase, the copper try to be expands more than steel. So ये तो आपको पता होना चाहिए और पता होगा भी. So let's understand this diagram. This diagram, to understand this diagram, आप समझो there is a certain step by step. So initially, my dear, initial position means when there is a no increase and temperature. So this is the initial condition of the bar. Understood? Are you getting? So this is this position, both steel and copper. This part is not here, suppose. So this one end is fixed, this like this, and this is this. So this is we are assume that this part is fixed one. So there is no expansion in this side. Expansion will continue only this side. Okay. So initial position is this. When the temperature increase delta T, then what happened? Because the this copper having the more coefficient of thermal expansion. If copper alone, if there is a copper alone, so it must be reached here. This is the here written that the position if the free, if it is a free, the copper must be reached at this position, is this position यहाँ तक आता. Okay. And if try to understand, if the steel is free, so it's come to this position, वो यहाँ तक आता. If both are alone, so steel यहाँ तक आता, copper यहाँ तक आता. जब दोनों फ्री होते, ठीक है, दो कंडीशन है. पहले इनिशियल पोजीशन व्हेन देयर इज नो टेम्परेचर इंक्रीज इन टेम्परेचर इन दिस पोजीशन, व्हेन if both are the free, so copper reach this till this position and steel reach till this position. यहाँ तक पहुंचा. If both are free, both are separated, but both are not separated, they are in combined, they are composite. So what the effect happened, let's see. Because coefficient in thermal expansion of this copper material is more, so it's that copper is trying to drag the steel, वो उसको खींचने की कोशिश करेगा और कर भी रहा है. And similarly, steel is also trying to drag back to this copper. So जो जब ये copper free होता है तो इस it must be reach till, but it is not free, so it will be stuck there. वो यहाँ में आके रुक जाएगा. इसको यहाँ आना था, यहाँ तक वो पीछे चला गया, और इसको यहाँ आना था, ये यहाँ आ गया. ये आपको याद, यह चीज अगर आपको समझ में आती है तो यू विल अंडरस्टूड दिस फिनोमेना. सो इस तरह के कुन में इस तरह की इसको आपको स्टेप बाय स्टेप आपको समझने की जरूरत है. बुक में डायरेक्ट पढ़ोगे नहीं समझ में आएगा. सो ये फिनोमेना हुआ है, यहाँ ये बात हुई है. इसको यहाँ जाना था, इसके कोफिशिएंट स्टील का कम है तो पीछे खींच लिया. इसका कोफिशिएंट थर्मल एक्सपेंशन इस भाई को पीछे रहना था, वो उसका बीच, तो दोनों ने बीच में सेटल डाउन हो गए. इसको पीछे रहना था तो आगे आ गया, इसको आगे जाना था तो पीछे हो गया. उन्होंने बीच का रास्ता अपनाया कि वो फाइनली दे आर रीच हियर. ठीक है, आप लोग फाइनली वो लोग वहां पर फाइनली दे रीच दिस पोजीशन. सो ठीक है. So now we're reaching this thing. So now let's move. So simply we are understand already. You know that this and this full expansion and all the theories there. No problem. I already given the notes. So the everything is mentioned there also. So we assume that हमने assume किया कुछ कि elongation in steel tube. Okay, like this. Okay, let's assume that sigma c is stress in copper, sigma s is stress in steel. Okay, and a is the cross sectional area of copper, and this is the cross sectional area of the steel tube or rod. ठीक है, उसके cross sectional area we are assuming that. So from equilibrium means say what? Because the tensile force acting in steel and compressive force acting in the copper क्या है, क्यों? Let's see. Because if it is a free, इसको यहाँ आना था पर इस फ्री नहीं है तो इसने पीछे की तरफ खींच लिया तो ये आ गया कंप्रेशन में. इस भाई को यहाँ रुकना था, इसने इसको खींच लिया तो ये आ गया टेंशन में. यही चीज है समझो. सो this you can see that in the under the equilibrium the tensile force on the steel and compressive force on the copper must be equal. So sigma s and sigma as equal to sigma c is equal to ac, and where alpha is the coefficient of thermal expansion in steel and alpha c is the coefficient of thermal expansion in copper. So now the elongation in steel there is elongation. So due to the elongation in steel, there is two type of phenomena is happening here. Due to the temperature के कारण elongation, and due to the tensile stress, because that copper is dragging to the steel. So there is a tensile, due to the tensile stress is also developed in the steel. So one is thermal and there is a tensile, equal to the elongation of the copper rod due to the temperature, and because it's compression, so minus sign will come here, and minus due to the compressive stress. So one is the plus, another is the minus. Always the compressive stress represent as a with minus sign. So temperature strain plus tensile strain in steel equal to the temperature strain minus compressive strain in the copper. So you know that the temperature strain का formula, you know that alpha s del t plus this is the normal tensile stress sigma s upon e. This you can find out the strain by this, and here alpha c is equal to del t and minus sigma c upon e, and just solve it. Keep sigma term is one side and alpha term is one side. Okay, so this formula is like this, and if you convert in term of strain, so you can also write like alpha minus alpha c minus alpha. So you remember this formula, always you remember this formula, so you will be able to calculate the stresses in steel or copper or in case in this example we have taken copper and steel, is sometimes they call say aluminium and steel, or aluminium or copper, it quite it possible. But you remember this formula change accordingly to which one having more alpha. So value of more alpha, so you can see here in this say this is steel, the value of alpha is less, copper is value of more. So here is a plus term, no problem, there is no effect on the here. But here you have to be remember that which alpha value is more, उसमें आपको जिसकी कम है उसको माइनस करना है। ये चीज़ आप एक साइड में अपने लिख सकते हो यहाँ से। जिसकी अल्फ़ा ज़्यादा उसमें आपको जिसका अल्फ़ा कम उसको माइनस करना है। वो कैसे पता चलेगा? न्यूमेरिकल में वो आपको दिया रहेगा वैल्यू ऑफ अल्फ़ा। ठीक है? सो यू मॉडिफाइड अकॉर्डिंग टू योर नीड, आपकी ज़रूरत के हिसाब से आप कर सकते हैं। ठीक है? So I think thank you so much for listening.